So we looked on the last page in the last video at how atoms can gain electrons or lose electrons in order to get a full outer shell, because of course atoms more than anything else want a full outer shell of electrons, and that's why they react, go into chemical reactions with other elements. Now, what we didn't say in those last pages is where those electrons come from or where they go to, because they can't just give them away or magic them up from somewhere. They have to have come from somewhere or go to somewhere. And so an element needs to work in conjunction with another element to gain or lose electrons. And that's what we're going to do here. So we have a look at the very basics of ionic bonding. So we've got here two elements here. Sodium with an atomic number of 11, so it's got 11 protons in the nucleus and therefore 11 electrons. And chlorine with 17 electrons in the shells surrounding the nucleus. Now you can't just look at those and figure out how that works. You need to draw them out. Okay, so often I see students look at this blank and say, can't do it. Well, we can all draw the arrangements of electrons. And if you can't remember, go back a couple of pages and it's all there. But just to remind you. The first shell holds, we'll put a dot for the nucleus to start with. The first shell holds 2 electrons, we've got 11 to deal with here. So the first shell holds 2 electrons, we're going to put 2 crosses to represent 2 electrons there. The second shell can hold 8 electrons, so 2 and 8 makes 10, and we've got 11 to deal with here, so this shell is also full. So 2 and 8 make 10, and this has got 11, so we need one more shell, one more electron, and that's now sodium drawn over here. So this has got 1 electron in its outer shell. So if we go back to the last page, it's got a choice. It could either lose 1 to get a full outer shell or gain 7, where it always goes with a lesser number. So it's going to want to, this sodium is going to want to lose that electron. Let's draw chlorine. 2 electrons on the first shell, 8 on the second makes 10. We've got 17 to deal with here, so that means the third shell has got to have the 7 in to make it up to 17. So chlorine here is going to want to lose 7 or gain 1. Where it goes with a lesser number, it wants to gain 1. So what happens is these two come to an arrangement. The sodium wants to lose this electron, the chlorine wants to gain an electron. So the sodium gives its electron to the chlorine. So we'll have an arrow starting at the electron and finishing at the gap, and we're going to label that E minus, because that's a nice way of saying electron without writing electron out. E for electron and negative because electrons are negatively charged. Transfer. We're going to label that. So what this now shows to anybody that is looking at our diagram is we know exactly what we're on about. The arrow starts at the electron and finishes at the gap. Now when atoms gain or lose electrons, they cease to be atoms, they become ions. They become ions, and the definition of an ion is a charged atom. A charged atom. Well, you can see the negative charge is going over to the chlorine. So that's going to be Cl minus. This is now the chloride ion. Now sodium has lost that electron, so that's going to become positively charged, Na positive. Okay? The name of this compound, well, these two have now reacted together and they've formed a compound. It was sodium and chlorine, and now it's sodium chloride. The ending changes. It tells us it's a compound of sodium and chlorine only. Now the formula of the compound, well, there's 1 sodium atom involved and 1 chlorine atom involved. So the formula is simply NaCl. Nice simple example. Check you've got that one, go to the next page. Okay, and you can do this one here, lithium and fluorine. I'm going to quickly talk through this next one now, a bit more complex example. Magnesium and oxygen. So dot for the nucleus, remember, we have to draw them out to see what's going on. Magnesium, 12 electrons. 2 in the first shell, 8 in the second. 2 and 8 make 10. Third shell, 2 electrons, 1, 2. Oxygen now, 8. Dot for the nucleus, 2 on the first shell, 6 on the second shell. Okay, so magnesium has got 2 electrons. It can either gain 6 electrons to fill the shell or lose 2. It goes to the lose 2, it goes to the lesser number. Oxygen's got 6 electrons on this second shell. It can either lose 6 or gain 2. It gains 2. Okay, so the magnesium gives its electrons to the oxygen, both of them. So we need 2 arrows this time. The arrows start at the electron, finish at the gap, and we label the arrow E minus transfer. Okay, and hopefully that arrow with that negative there, that negative is heading towards the oxygen, so that's now going to be O. Now if you write O minus, you're not wrong, but you're not right. It is negatively charged. The negatives go over here. It's not O minus, it's O2 minus. Now these are superscripts, they're written high. Charges on ions are written at the top. That's very different to O2. That's a completely different, that's a molecule. That tells us it's a molecule made of 2 oxygen atoms. Okay, that's not right. It's O2 minus, the 2 is up high. Magnesium has lost electrons, it's lost the negative charges. Okay, so that's going to end up positively charged. And it's not just 1 positive charge, it's 2 positive charges, Mg2+. Name of the compound, magnesium oxide. Magnesium oxide is a compound of magnesium and oxygen. The formula, 1 magnesium, 1 oxygen, so the formula is MgO. Okay. Right, let's have a quick look at this example here, magnesium and fluorine, and then I'll leave you to do the next one on your own. So, magnesium has got an atomic number of 12, so that's 2 electrons on the first shell, 8 electrons on the second shell, 2 and 8 makes 10, and 2 electrons on the third shell. We've just looked at magnesium, haven't we? Fluorine this time, 9. 2 electrons on the first shell, 7 electrons on the second shell. So magnesium wants to lose 2 and fluorine wants to gain 1, so it's no surprise, is it? The magnesium electron, arrow starts the electron, finishes at the gap, label E minus transfer. Okay, and now students start to get themselves confused because I say, what about this one? And some of them like to put it over there to the fluorine, can't do that. This fluorine has now got a full outer shell of electrons. Then they think, well, I can't do that, I'll just leave it and just say it's finished. It's not finished because this magnesium doesn't have a full outer shell of electrons. It's got to go somewhere. Okay, it can't just stay there, it's got to go somewhere. So the only thing you can do is either draw another magnesium or draw another fluorine. That's all you can do. So which should we be? What should we do? Well, this magnesium wants to lose electrons. So what is accepting the electrons? Answer, the fluorine is accepting the electrons. So we need to draw a whole nother fluorine. Let's just do it down here. I haven't left myself a huge amount of space, have I? 2 electrons on the first shell. Fluorine's got 9 electrons. 7 electrons on the second shell. 1, 2, 3, 4, 5, 6, 7. And there our electron transfer goes from there to there. E minus transfer. Okay, so the charges on the ions. Magnesium has lost 2 electrons. That's going to end up Mg2+. Fluorine here. Fluorine has gained 1 electron. So that's going to be F minus. And you've got another fluorine there, that's also F minus. So if you want to write F minus twice, I don't object to that, that's fine, but we can just write F minus. Name of the compound, magnesium and fluorine. A compound of magnesium and fluorine is called magnesium fluoride. We always write the metal's name first and the non-metal second, magnesium fluoride. Now the formula of the compound, we've drawn 1 magnesium and we've drawn 1, 2 fluorine, so it's MgF2. Right, you can have a go at that one on your own. And we'll quickly have a look at this aluminium and chlorine here. Aluminium 13. Okay, it's got 13 protons in the nucleus, therefore it's got 13 electrons in shells surrounding the nucleus. 2 on the first shell, 8 on the second shell makes 10, and 3 on the third shell makes 13. 1, that's 1 there, 2, 3. Chlorine, 17 electrons. 2 on the first shell, 8 on the second shell, 2 and 8 makes 10. 7 on the third shell. So looking at this, we can see chlorine has got 7 electrons in the outer shell, so it wants to gain 1. Aluminium's got 3 electrons in the outer shell, it could lose 3 or gain 5. Well, it's going to go for the lesser number, losing 3. So we can put an arrow there, starting at the electron and finishing at the gap, E minus transfer. Okay, this is now happy. The aluminium isn't. It's still got 2 electrons. So they've got to go somewhere. We either draw another aluminium or another chlorine. Well, question, what is accepting electrons? Answer, Chlorine, so we need to draw another chlorine. Okay, we don't draw another aluminium because aluminium wants to give electrons away. We're wanting something to take electrons. Chlorine is taking electrons, we can see that. Draw another chlorine. 2 on the first shell, 8 on the second shell makes 10, and 7 on the third shell. 1, 2, 3, 4, 5, 6, 7. And we'll have an arrow going from that electron to that gap there. I haven't left myself enough space here, which is a recurring theme in all these videos. E minus transfer. Okay, so this chlorine is happy. This chlorine's happy. This aluminium's still not happy because it's got that electron it wants to give away as well. So do we draw another aluminium or another chlorine? Answer, we draw another chlorine because chlorine's accepting electrons. Dot for the nucleus. 2 on the first shell, 8 on the second shell, 17 in total. And 7 on the outer shell. Arrow starts at the electron, finish at the gap. E minus transfer. Always write that E minus transfer. It just shows you know exactly what you're about. And also it shows you which way the negative charge is heading. So it shows us that the chloride ion is going to be negatively charged. Now the aluminium ion, it's lost 1 electron, 2 electrons, 3 electrons. It's going to be positive, but it's going to be 3 positive, Al3+. Name of the compound, aluminium chloride. Formula of the compound, 1 aluminium, but 1, 2, 3 chlorines, AlCl3. The last one down there, that's horribly difficult. Certainly won't be on a GCSE, but if you want to have a look at it, feel free. Good luck.